Unit 7 introduces us to one of the most important things you do in any level of math. It's called factoring. Trying to figure out two things that multiply together to get us something. We also can call factoring undistributing. So for example, if I gave you 2x times x plus 3, which is what we did yesterday, you would realize that this was a monomial being distributed to a binomial. And you would multiply 2x times x and get 2x squared. 2x times 3 gets you positive 6x. Well, today we want you to go backwards. I'm going to give you the answer. So I'm going to give you 2x squared plus 6x. And you have to figure out what polynomials or monomials were multiplied to get that answer. So you're going to have to come up with the 2x squared and the x plus 3 being multiplied together.
Ready. Let's go.
All right, so here's our first set of examples. Let's see what we can undistribute. So distribute meant to pass into something. So what is common is what we're looking for. So let's keep that word. Let's keep that word handy. What's common? What does it look like everybody got? Well, if I look at this, I look at this one. Well, what's common to 6 and 18? 6. So it looks like I passed a 6 out. All right, so 6, then that would have been y squared, because 6 times y squared gets me 6y squared. The plus sign, and then must have been a 3 there, because 6 times 3 gets me 18. There. I undistributed. It's like when I tell you to pass papers forward in class, like when I recollect your tests or whatever. You pass them forward, you undistribute them. All right, for number 2. Well, number 2's got a lot more letters in it and bigger numbers. So let's do one at a time. Let's look at 27 and let's look at 18. And remember, what's common to 27 and 18? A 9. But we're not done yet. This has a y squared. This has a y to the 5th. Is there anything that's common to y squared and y to the 5th? Yes. Y squared. And then that's it. Even though this guy has a z, that is not common to this first term. Okay, so now we can start seeing what's left over now that we've figured out what's in common. So 9 times 3 is how we'd get to 27. Y squared times, well, we don't need any more y's here. So I guess 9y squared times 3 gets me 27y squared. Plus 9, this would have to be a 2, because 9 times 2 got me 18. Y squared means this must have still be y cubed left over. And then poor little old z, he wasn't in common to anybody, but he's got to hang out there anyway. Now if I were to distribute, I should come back with my original problem, and I do. Number 3. Now we have a little more. We have a trinomial. So we're still going to see what is in common to all 3 terms. Well, one thing I notice is that they don't all have variables. And in fact, This is the variable b and this is the variable a, so there are no variables in common. So all I have to do is look at what was distributed to a 21, a 15, and a 3. And it was the number 3. So 3 times 7 is how I got the 21, and there's still a b there. So 3 times 7b is 21b, minus sign. 3 times what got me 15? 5, and there's still an a there. Yep, 3 times 5 is 15, and then the a. And then careful, I have a third term here, I have 3. Well, 3 times 1 is how I got 3. So there I undistributed that one. So by now you're getting the hang of it, and it should be pretty easy to do. I'm going to undistribute here. Well, there's a 3 in common, no variables. So yeah, you may say undistributing is kind of like dividing. You're right, we're dividing. We divided each of these terms by 3, and then we have what's left over. All right, number 4. I see that they have C's. And in fact, the most I can distribute to each one was just 1. Now let's look at the numbers. 14, 2, and 4. What's the biggest number that goes into 14, 2, and 4? Just little old 2. So now I see that I distributed a 2c to everybody. Well, if I undistribute a 2c, in other words, I divide everybody by a 2c, it's 7 c to the 4th plus 2 c to the 3rd minus 2. Now you can see that there are still c's left inside, but not everybody has a common c. So we could only have taken out undistributed 1c. So good, I hope you're understanding undistribute. We see what goes in and then what comes out. What goes in, what comes out. What goes in, what comes out. Oh, I'm having so much fun today with my little characters. All right, just a real quick. If you noticed, everything on the last page, there was a monomial being distributed to binomials or trinomials. Tomorrow, we're undistributing binomials to binomials. But just to give you a little look at what that would look like, well, if we look here, that's one term, and that's another term. We did these in the beginning of the year. What is common to this first term that's common to the second term? That's right, an x minus 3. So we are going to undistribute the x minus 3. And we're left with an x and then the minus 6. So see, that's a binomial to a binomial. Same thing right here. This is one term and this is another term. What was common to this first term that was also common to the second term? That's right, the x plus 5. So I had passed out an x plus 5 to an x plus 2 and an x plus 1. And if we rewrote that by simplifying, that's what we would get. So again, we're going to do more of this tomorrow, but just to bring it to the forefront, because we have done it in the beginning of the year, same thing, what's common here. Okay, I distributed an x minus 2, so we're going to undistribute that x minus 2, take it out. We're left with an x, a plus 3, a minus x, and remember this is a minus 6, because the minus has to get distributed. Oh my gosh, there's so much distribution going on today. X minus x cancels out, and 3 minus 6 is a minus 3. Oh, look at that one. That turned into a binomial and a monomial. But anyway, we just wanted to review those. We'll see more of them tomorrow, and I can't wait.